Hey guys, we're doing some test review here, and we're talking about how to solve systems of linear equations in this one. So right now we're looking at targets 20, and we'll see how far we get in the first little bit here. So we have a bunch of different options to solving a system of linear equations, and one of them is elimination. So you really want to figure out what method works best. So in this problem, elimination is going to work the best because we have the x's and the y's and the numbers all lined up. It doesn't matter so much that the equals is right there after the x and y, but that's the normal format for this. Now in this particular case, I can add them straight down because the y's are going to be eliminated. So in this case, it would be 5x. The 4y's both cancel out, and 7 plus 13 would be 20. And then we solve this little equation that only has one variable because the other variable has been eliminated, which is kind of the idea here. So the method in this case is the elimination. And that's because they're all lined up. Now, from here, we're going to solve for x by dividing by 5, because it's 5 times x. Get rid of that multiplication of 5 by dividing by 5. We get x to be 4. And we have to make sure that we always write our solution as an ordered pair, because these are two lines. And we're looking for the intersection of the two lines, which we'll look at in the graphical one here in a second. Once we know what x is, then we take that x and we plug it into either equation. It doesn't matter which one. And we then solve for y. So I plugged into the first equation because they're both about the same difficulty. So it doesn't really matter too much which one I choose. And now I'm going to solve for the y. Subtract the 12 over from both sides. You get 4x equals 5. Sorry, negative 5. And then I divide by 4. And I get x to be... y to be negative 5/4. Now I chose to eliminate the y's to begin with because these x's are not exactly the same. However, I can do elimination using the x's. All I have to do is I have to transform this 2 and the 3 to be the same number. And you really want to do this when these y's aren't set up quite so nicely for you. So for example, I can make this one become a 6 by multiplying by 3, and I can make this one become a negative 6 by multiplying it by negative 2. And the reason why I want to multiply this by negative 2, so that becomes a negative 6x minus 8y equals negative 14, and I have to make sure I multiply everything by that negative 2. And then in the second equation, which I'm going to put straight across here, I'm also multiplying everything by 3, so 6x minus 12y equals, that's a little bit tougher, 39. Now, they have to be the same number, but they also have to be opposites, which was why the y's went so well when we did this the first trial through. But it really doesn't matter which variable you pick, because now, when I add these together, I get negative 20y. The x's are going to get eliminated, equals, and this ends up becoming 25. Divide by this negative 20. And we get y to be, and you gotta reduce it. You can take a 4 out of both of these, sorry, 5 out of both of these, and you get negative 5/4, which is the same thing we got a little bit ago. Now in this case, I still have to plug this into one of the equations. So 3x plus 4 times my y, which would be negative 5/4, equals 7. And I solve it out, and I'm going to get the exact same thing. And I'm better, because if I don't, that means you're doing something wrong. So if you can't do this by hand, put it in the calculator. In other words, you put this over 1, 4 on top and 4 on bottom, they cancel, and that's where I get my negative 5. Add the 5 over, get 3y equals 12, and divide by 3. Y equals 4. X. I keep on changing letters somehow in the middle of these problems. So x equals 4, and I get again 4 comma negative 5/4. So anytime that they're lined up, that's generally when I'm going to use elimination. That doesn't mean I couldn't use substitution, which is not the next method we're going to look at, but graphing would be a bad choice in this case because I don't have these in y equals mx plus b. or in the point slope form either. So that would require a little bit of work to get there. All right, let's look at the next one. So in this one, it is in y equals mx plus b form. Now the part that's annoying here is there's not a graph handy. Actually, let me see, is there one at the bottom of the page here that we can just steal? No. So when we saw this on the quiz, there were graphs just to kind of use if we wanted to use them. So we got two options. We can either abandon the graphing method, or we can try to graph them. And when we graph them, we have to be kind of precise. And this medium for graphing, for me, is not exactly the easiest, but we'll do our best. So there's a quick graph. First one starts up at 1. It goes up 3, over 1, up 3, over 1. Then I could go down 3, over 1. So there's my first line. Starts with the y-intercept, always. Y-intercept goes there. And then use your slope second, 3 over 1. The other point goes up 1, 2, 3, 4, 5. It has a -1 slope, so that -1 over 1 makes me go down 1 over 1. And now I can keep drawing this if I want to, but this point right here is the point that I'm looking for. And it's 1, comma, 1, 2, 3, 4. So it's 1, 4. And the method we use is graphing. And why? Because they were in y equals mx plus b form right off the bat. Here's the other thing. Let's say you don't want to draw that graph right there kind of just out of nowhere. This is kind of a tricky thing to do, and if you're not careful with it, you'll not be able to find this intersection point right here. So the other option is, substitution is a good option for this, because you have y equals, right? So I know y equals 3x plus 1, so I can plug that into the other equation. So 3x plus 1 equals -x plus 5. So anytime that you have y equals or x equals, you can solve by substitution, which I can show you that this gives you the exact same thing, but that's the next topic in a second here. So I'm going to leave that one be, and you can verify that this will give the exact same solution that we got a minute ago. Actually, before you go to this one, you should pause the video now and go back and finish that one by substitution. But if you don't know how to do substitution, I guess watch this and then go back and try to solve that one with a substitution. Now, this one's going to be substitution. And you really want to use substitution anytime you have y equals a number or x equals something like 3x minus 5 would be another good substitution problem. Oh, sorry, 3y minus 5. You don't really want to mix the variables. If you have a y on this side better be x's. Alright, so we know that y equals 2x plus 3, so we're going to take this 2x plus 3 and plug it into the other equation. So the other equation is 15x minus 5, but instead of y, we have this 2x plus 3 equals 30. So this is the same equation. This was y, but I know y equals that 2x plus 3. So the next thing we're going to do is we're going to distribute. So this -5 gets distributed into both of the pieces. Let's see what we get. 15x minus 10x, and then don't forget that -5 goes into positive 3 as well. Minus 15 equals 30. So now we got an equation with no y's and a couple x's. So we're going to combine like terms and remove this 15x, or 15 just number over to the other side. So that's our step. So we're going to add 15 to both sides to move that 15 over. And our 15x minus 10x would make 5x equals, these 15's cross out, 30 plus 15 is 45. Divide by 5, divide by 5, get x equal to 9. Now, when we do the solution, we still need to find our y, but that's this box thing right here. I've got y equals. So y equals 2 times 9, because that's what x is, plus 3. So y equals 18 plus 3, or 21. So this is substitution. And why was it substitution? Because this thing is accumulating arrows over here. That is y equals. So anytime you have y equals an equation, or x equals an equation of some sort, whereas y equals an equation in terms of just x's, or x equals an equation just in terms of y's. anytime you have that, you can plug these in. Now this is kind of tricky because I could say that this y equals goes with graphing. But in the other equation, it's not also y equals. So you got to choose which method you want to do. So let's finish this up and we'll do the application problems as well. So the last part of this video is the application problems. Let's move there now. Alright, before we get to the application problems, I want you to try to solve these two on your own. But let's discuss what method we should do. So you should pause it now. Think about what method you're going to do, and then once you've decided your plan of attack, then resume the video. So pause it now, think about it, and then come back to us. Okay, so what I think you should be doing in this problem is elimination, because they're all lined up. You have your x's, you have your y's, you have your numbers. Now, you have the choice. You're going to get rid of the x's, you're going to get rid of the y's. If you want to get rid of the x's, you'd have to make them both become 10. Think of it like at least common denominator. So between the 2 and 5, I multiply this one by 5, and this one by a negative 2. It doesn't matter which one gets the negative, but they have to make a negative 10. If I wanted to make the y's go away, I'd have to make the first one become a 6, so I'd need a 2 here, and I need to make the second one become a 6, so I'd put a negative 3 here. And I would say the exact same thing about number 5. It should be elimination as well. I personally go with the x's again, so I multiply this one by negative 3 to make 15, and I multiply this one by 5 to make 15 as well. You have to multiply everything by them to make this happen. Once you do, then you're good.